students, in this video I'm going to tell you how to calculate the number of sigma and pi bonds in a molecule. Now what are sigma and pi bonds? I'm not going to go into the detail of how the sigma and pi bond is formed, but in general a sigma bond is the very first covalent bond that is formed between two atoms. For example, if I have a carbon-carbon, I have two atoms of carbon, the very first covalent bond that would be formed between the two carbon atoms is called as a sigma bond. Now if I have a double bond, see, I'll write it like this. If carbon-carbon single bond, I have one sigma bond only. Now if I have a carbon-carbon double bond, as I told you, the first bond formed is always the first bond formed is always the sigma bond. The other bond is your pi bond. So in a carbon-carbon double bond, I have one sigma bond plus I have one pi bond. Similarly, if I talk about carbon-carbon triple bond, I will say the first bond is your sigma and the other two are your pi bond. So in a carbon-carbon triple bond, I will say it is 1 sigma plus 2 pi. Now I'll tell you a trick to solve such questions for your entrances wherein a very less amount of time would be required. So now if you have to calculate number of sigma bonds, the formula is you can count the number of total atoms in that particular molecule or in that compound minus 1. Now how will it work? For example, I have the simplest molecule, that is methane, and how many number of atoms are there in methane? There is 1 carbon and 4 hydrogen. So in total 5 atoms are there. So how will you calculate the sigma bonds? Sigma bonds would be the total number of bond, which is 5 minus 1, it would be 4. Now let's cross check it. If I make the structure for methane, I have 1 sigma, 2 sigma, 3 sigma and 4 sigma. I have 4 sigma bonds. So yes, this formula works. But for number of pi bonds, you will have to draw the structure and then only see if there is a double bond or a triple bond in that particular molecule. Then after eliminating the sigma bonds, you will have to calculate the pi bond. And also please remember that the formula that I have just written is only for the aliphatic compounds. Do not use it. Do not use for ring structures. So now I'll take few more examples so that the concept would be more clear. Now this structure, this is CH triple bond C, CH double bond CH, CH3. Now it is very difficult to just look at it. You'll have to draw the expanded form of the structure. This is the condensed form. So if you have to draw the entire formula, that would take time. So what I'll do is I'll first use my trick. Trick says 1, 2, 3, 4, 5, 6, 7, 8, 8 plus 3, 11. So total number of atoms present in this particular molecule are 11. So if I have to calculate the sigma bonds, it is going to be 11 minus 1, which is 10. Now I'll also write the expanded form of this molecule. Now this compound would look like this when you will expand the structure here. So now if I will start calculating, you can easily calculate that this is your sigma. The very first out of the triple bond is also sigma. This is sigma, this is sigma, this is sigma. So like this you can write or you can directly calculate. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. And yes, that is the same number of sigma bonds that I calculated using my formula. So now if I have to calculate pi, from pi, if the first one was sigma, here are 2 pi here and 1 pi is here. So the pi bonds are 3 in this particular structure. If I'm talking about a structure like this, now how many total atoms are there here? So it is 1 plus 2, 3, 4, 5, 6, 7 plus 3, 10. So 10 minus 1 would be 9. So now let us also draw the expanded form of this structure. Now this would be like this. So now if I start calculating the sigma bonds, it is going to be 1, 2, 3, 4, 5, 6, 7, 8 and 9. So now this is right. Now if I have to calculate the number of pi bonds, it is going to be 1 from here since it was a double bond, and here it also was a double bond. So 1 sigma has been taken away. So this is 1 pi and 2 pi. So the number of pi bonds would be 2. Now if I talk about this structure, the number of atoms, total number of atoms here would be it is going to be 1 plus 2, 3, 4, 5, 6, 7, 8 and 9. 9 minus 1, it should be 8. Now if I expand the structure with all the bonds that are there, I can easily calculate. Now this is sigma. This is 1, 2, 3, 4, 5, 6, 7 and 8. And it is right, sigma are 8. And what about pi? I have 2 double bonds here. So 1 and 2, I have 2 pi bonds here. Similarly, if I talk about this structure, how many sigma bonds are there? Now let us also use the formula. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 minus 1, total number of sigma bonds should be 9. So now let's calculate. It is 1, 2, 3, 4, 5, 6, 7, 8 and 9. And what about pi bonds? It is 2 here. Out of the 3 triple bonds that are here, 1 would be the sigma and the 2 would be pi. So 2, 3, 4, 5, 6, 7, 8, 9. So how many pi bonds are there? 9 pi bonds are there. Now this is the structure of benzene, and we know that every corner is a carbon and it has a hydrogen. C6H6 is the formula. So now if I calculate the number of sigma bonds here, so I can clearly see I have 6 sigma bonds outside, that is a carbon hydrogen sigma bond. Now apart from this 6, I have 7, 8, 9, 10, 11 and 12. So totally there would be 12 sigma bonds, right? And how many pi bonds are there? There are 1, 2 and 3 pi bonds. Now I am again repeating that you cannot use that trick formula here for the ring structures or the benzene derivatives. See, if I use that formula here, what is the formula for benzene? It is C6H6. So the total number of atoms in this particular compound would be 12, and 12 minus 1 would be 11. So from my formula I will get 11 sigma bonds, rather, which I have already seen after calculating that they are 12. So I am again saying that do not use that trick for any compound which is not aliphatic. I hope the concept is clear now.